What we're looking at today is the last section of Chapter 1, the last part of Chapter 1, and we're looking at angle relations, or angle pairs. Now, the first set of angle pairs that we have are complementary angles and supplementary. The big thing with complementary angles is that it's two positive angles whose measure have a sum of 90 degrees. Each angle is the complement of the other. So complementary angles means that the two angles add together to be 90. Now, supplementary angles add together to be 180 degrees. Two positive angles whose measures have a sum of 180. Each angle is the supplement of the other. So complementary means 90. They add together to be 90. Two angles add together to be 90. And supplementary means the two angles add together to be 180. They make a straight line. Complementary is 90. Supplementary is 180. And it's only two angles. We can't have 3, 4, 5. It's only two. So complementary means that we have two angles that add together to be 90. Supplementary, two angles add together to be 180. Adjacent angles. Adjacent angles, there is a lot here. The big thing with adjacent angles is that they share a common vertex and a common side. For two angles to be adjacent, they need to share a common vertex and a common side. If they do not share a common vertex and a common side, they are not adjacent. So these here would not be adjacent. These here would be because they do share a common vertex and a common side. They are next to each other. So the real big thing we can say with adjacent is common vertex, common side. Common vertex and side. Okay. In the figure, so here's our first example. In the figure, in this figure here, name a pair of complementary angles. Yes. RST and BAC. Those two. So we could have named them RST, TSR, or angle R, because we could use one of those three. And for the other one, we could have said BAC or CAB. We couldn't use angle A because there are more than one angles at that spot. But those two would be the complementary because why? 90. 37 and 53 do add together to be 90. Now our supplementary. Yep. That may be why they look a little different. The pages might be, yep, they are. I noticed that now. Questions on complementary and supplementary? Name a pair of adjacent angles. So CAB and CAD. Because for them to be adjacent, there's two traits that they need. A common vertex, which CAD and BAD do share. They do share a common vertex. But we need what else? A common side. So technically they do share a common side, but we'll go with, it's going to be more accurate to say BAC, angle BAC, and angle CAD, those two, because they share that side length of AC. Because the other BAD would be angle CAD would be contained in angle BAD, so they're not really adjacent, they're contained within each other. Any other questions on this here? We good? Okay. Angle 1 is a complement of angle 2. So what does that mean? Angle 1 plus angle 2 is going to equal what? Well, they told us what angle 1 is, didn't they? 62. Yeah. So really we can just subtract 62 from 90. 90 minus 62 is 28 degrees. And that's it. Goes 63. Because 1 and 2 add together to be 90, so 62 plus the other angle is 90. Well, I can subtract 62 from 90 and get 28. Ready for the next one? Oh, front page. Yep, there's a picture. 3 is a supplement of angle 4. And the measure of angle 4 is 47 degrees. Find the measure of angle 3. Minus 47. Is supplement, we know they add together to be 180. So I can really subtract 47 from 180 and get 133 degrees is going to be the measure of angle 3. Because either one of these ways works. It's the same thing. Because we could have started off with the measure of angle 3 plus the measure of angle 4 equals 180. Substitute 47 degrees in, subtract from both sides, and find out that it's 133. Or we can just do this here. Question? Let's look at this one here. Name a pair of complementary angles. Yep. Yeah, so we're back to the first page. I got them out of order. Yep. Either that or I set up the prints, ran it, switched the sides because I didn't like the order and never switched the print offs. Okay. So we have 3 things going on here: complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Okay, and what was the second one? GKL would be complementary. Yeah, so you can do comp and sup for those. So what would be our supplementary angles? What's G? is our supplementary. And we also need our adjacent angles. K, G, what? And KGH. Because both of these angles share the side KG and the vertex G. They have to share a side and an angle, or side and a vertex. Common side and common vertex. Questions on this here? Are angles KGH and angle LKG adjacent angles? So K, bless you, bless you. I can do this in a different color.
Can you explain the rule of that?
So adjacent has two main things. What are they? Common what? Common vertex and common side. So angle KGH, vertex is where? So KGH is there, yes? Vertex for LKG. Do they share a common vertex? No. So, no, because no common vertex. Now the second set it asks about are FGK, FGK, and FGH. So they do carry a common vertex, yes? No, because no common side. Because they need a common side for these two to be adjacent. Any questions on this here? Yep. Okay, that makes sense. I think the main confusion with that one, if I go back to this here, there's one thing I didn't point out with this, and is this last statement here. But no common interior points. That's the issue with that one. That's why that last one was false here, is because, that's what I was going back on a little bit, because technically this is a common side, but all the interior points here are shared in both. That was, I think, the issue that we were having. So yes, it does share a common side, but the interior points. That's what I was looking up and making sure. So if one is contained within the other, it doesn't work. So adjacent has to be common side, common vertex, and no interior common points. One cannot be contained within the other. Does that kind of answer your question? Yeah. So if one's inside the other, they are not adjacent. I think those slides in here are out of order. There, they're fine. 1 is a complement of angle 2. The measure of angle 2 is 5 degrees. Find the measure of angle 1. Is these two add together to be? Any questions on this here? 3 and 4 are supplementary angles. The measure of angle 3 is 148. Supplementary means? And what are we going to subtract from it? 148, 32 degrees. This is going to be the measure of angle 4. Questions on this here? We good with this here? Awesome. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and measure of angle ECD. Supplementary means what? They had together to be 180, yes? So that means that our two angles, the 4x plus 8 plus the x plus 2 is equal to, they have together to be 180. And we're setting this up to find the value of x, because once we find the value of x, we can plug it back in to find each individual angle. What can we do first? Combine like terms. 4x and x is, 8 and 2 is. What can we do next? We can minus 10. How many times does 5 go into 17? 3, which is 15. 20, which is 34. So that's the value of x, yes? So we have to plug it back in. So we can take 4x plus 8 and plug 34 in. So 4 times 34 plus 8. 6, carry the 1, 12, 13. 144 degrees is going to be the measure of angle BCE. BCE equals 148 degrees. And again, we could have typed it in at 4 times 34 plus 8, typed it in and gotten our answer. Now the other one is x plus 2. 34 plus 2 is, and this here is going to be the measure of angle ECD. And you're right, that is not 148. That should be 144. Yeah. Straighten. No? Tanner. I'm going to get this. Yeah, Tanner, it was 144. I saw the confused look on your face, and I'm like, I know something's wrong up here. So 144. And another way, again, that we can check is, again, that these two should add together to be 180. So 36 and 148 was not going to give us 180 because I needed a 4 with that 6. 6 plus 4 is 10, so 0 carry the 1. 3, 4, and 1 give us 8, and we have our 1. So that would be 180. So this here would be the correct answer. So when we plug it into both equations and then check to see do they add together to what we're supposed to be, we can check it that way. Now, if we'd have just subtracted it from 180, we would have actually gotten the wrong answer. Because if I had 148, because that was wrong, and I subtract that from 180, it would have told me the other angle was 32. So if we subtract it from the 180, if we have the wrong answer on one of them, it'll give us a wrong answer on the other. So it's sometimes good to plug it back into both and see, does it work out? Questions on this here? I think we have... Do we need to see another example of finding the complementary angles? We're good? Angel? Okay. I believe this here is the last concept that we're going to look at. Linear pairs and vertical angles. Two adjacent angles are a linear pair when their non-common sides are opposite rays. The angle is a linear pair, are supplementary angles. Really, if two angles, one of their sides makes a straight line, they're a linear pair. Linear pair, linear line. We're talking about two angles that make a straight line. Are a linear pair, and they are supplementary. They add up to be 180. Two angles are vertical angles when the sides from two pairs of opposite rays. When their sides form two pairs of opposite rays, they are vertical angles. And we'll get more into vertical angles. Vertical angles have some unique properties to them. But we'll cover that at a later date. No, that literally, oh, we got 2 pages left. Yep. We good with this here? Anybody still writing? Okay. Okay. Identify all linear pairs. So linear, angle 1, and wouldn't be angle 2, because linear pairs make a straight four. 1 and 4. Now it looks, well, angles 1, 2, and 3 do make a straight line. Yes, if we add those together. But why would they not be a linear pair? So what are we talking about? Linear what? What is a pair? 2, yes? So angles 1, 2, and 3 is 3 angles, not 2. Because if we're talking about linear pairs, we're talking about 2 angles. So 1 and 4 work. Any others? Almost. Because I would say 5. But yes. 4. Does 4 and 5 make a straight line? Yes? 1 and 4 make a straight line. 3 and 4, 5 don't. They don't make a straight line. Because a linear... Yep, so linear pair, the key part of it... Straight, yeah.
I was looking at just one angle. Yeah.
Yeah, the definition says if they're a linear pair, their non-common side, the one that's not shared, are opposite rays. So if we looked at 3 and 5, well, those don't make opposite rays. It needs to be a straight line.
So would 1 and 3 be 1?
1 and 3, opposite ray, yes? And where's their common side? Good. Linear pairs, their non-common side they need a common side. 1 and 3 don't work. There is no common, because what do they also do? They also they add up to be 180. Do 1 and 3 add up to be 180? No, because angle 2 is in the middle, so they're not a linear. Okay, so let's look at vertical angles, because those are the only two linear. So vertical angles, let's look back at the definition. Two angles are vertical angles when their opposite, or their sides form two pairs of opposite rays. So 1 and what? So 1 has these two here, yes? So I need opposite rays to it, so they would go in the opposite direction, yes? So this would be an opposite ray to one side of 1, yes? Where would the other one be? Going straight down. Because two opposite rays, well, that would be angles 1 and almost. And that's the only one.
How do you tell, like, for 5, how's it not, like, 4 if they're all, like, how would you know that?
So sides form two pairs of opposite rays. So where's the opposite ray going from this one here? It's going this way here, yes? And this one's opposite ray is going which way? Down here, yes? What angle is contained? 5 and 1. Because if we looked at angle 4, I'm going to erase all this here. Angle 4 has this one here, yes? Its opposite ray would be. Now, the other side is here, and its opposite ray is going straight up, yes? Well, 4, and then we have what? 2 and 3. But again, we're talking about vertical angles is going to be a pair, only one. So since, yep, those don't work. Any other questions on this here? So here there's only one vertical angle. If it wasn't for the fact that 2 and 3 were split, it would be. That whole angle would be. Okay. And I think this is the last one on this page. There's one other page, but it's just a picture, isn't it? Yeah. Let's look at this here. Two angles form a linear pair. Linear pairs do what? They add together to be 180. They make a straight line. So really we're talking about something like this here. The measure of one angle is 5 times the measure of the other. So one of our angles we would say is what? And the other is? One angle is 5 times the measure of the other. One is going to be x and the other is going to be 5x. So we can say 5x plus x is equal to 180, because I do know those two angles add together to be. Right? So this here would be 30 degrees. Over here we have 5 times 30, which is 1. And that's it. Questions on this here? You good with this here? Okay. We're going to look at this one here, and then we have one other thing, and we are done for today. Do any of the numbered angles in the figure form a linear pair? So they do have a common vertex, yes? Their non-common sides do form opposite rays, yes? And their common side is where? Well, because 1 and 5 don't share a common side, do they? Okay. Will any of these share a common side? Mm-mm. So no, there are no linear pairs. I will tell you there are some vertical angles. Angle 1 and what? 1 and 4. What else? 6 and 3. Two and 5. 6 and 4 would not. But if we look at this here, let's pull this up. This one, I want 2 arrowheads, and we're going to color it red. So I have this line here. One that's yellow, and then let's say blue. So when we look at this here, we're looking at the ones that do have opposite rays for their sides, yes? So 1, so we have yellow and blue. Well, the only one that shares that is 1 and 4 have those opposite rays, yes? So if we look at 6, we have red and blue. Contained between red and blue is 3. So 6 and 3 are opposite rays, or opposite, or angle, vertical angles. So 6 and 3, 1 and 4, 2 and 5, because we have yellow and red, so those two match up. So if it does help to draw those out, those opposite rays, to see where they're at, go on and do that. Any other questions on this here? Okay. I'm not going to worry about those. But this here is the last thing we're going to look at. Interpret a diagram. There are some things you can conclude from a diagram, and some things you cannot. For example, here are some things you can conclude from the diagram below, this here. All points shown are coplanar. They're contained within the plane. As we don't have an actual plane drawn, they are all in the plane. We don't have restrictions on that. Points A, B, and C are collinear. They're on a line. They're on the same line. And point B is between A and C. We can assume that. We can conclude that. We can also conclude that AC is a line, BD and BE are both rays, and they all intersect at point B. Because that is there, we can conclude that. We can conclude that angle DBE is and EBC are adjacent angles, common vertex and common side. Hold on for 1 second. ABC is a straight angle. It's a line. It's a straight angle. And point E is in the interior of angle DBC. Now, again, focus up here. You can back up in a second. There are some things we can't conclude. We cannot conclude that AB and BC are congruent because we're told nothing about point B, that it's in the middle. If we're not told it, we cannot assume it. We cannot assume that DBC is a right angle. It doesn't have the square. It does not tell us, because unless we're told it, we cannot assume it. And we cannot assume that these two angles are congruent. We must be given the information. And that is it for this chapter. We are done with chapter 1.6, and we are also done with chapter 1. This is also posted up in Google Classroom for 1.6, or will be here in a minute, so you can see it there too.